I don't think you and I have much choice. We have to go back to my definition. So going back to my definition of derivatives, I think f prime of x can be interpreted as a ratio of this difference to h. Oh shoot, I misspoke. S specifically is a sine function. I guess it's, I've got the sine of x plus h minus sine of x all over h. Do you guys agree? But this is nothing more than, shoot, you guys, I need some help. How do I evaluate the sine of the sum of two different terms?
Multiply it by its whatever.
It was such a nice pen, it's all dried out.
Sum of two differences.
Isn't it like sine cosine?
Yeah, it's
Sine of x cosine of h
Minus
plus.
cosine x sine h.
Oh, that was very nice. All over h. Yes. You guys there?
Yes.
You make me nervous.
Alpha, beta.
You don't remember that at all?
That was a long time
I
ago.
remember it. Yeah.
Or shall I say, oh, I shouldn't say anything, you guys, I've done something horrible. Really horrible. Serious. Don't you agree? Seriously. Ay, it's late. Sorry, you guys. Christian, I'll get out of the way. I didn't write the limit. And if you guys don't mind me just reorganize my terms. Is that the same as a limit as h does this thing of how about, I got an idea, the middle term. Plus a limit as h does this thing of everything else left over. Is that the first term? Plus a third term? Which is nothing more than the limit as h goes 0 of, I got an idea. I think the limit of a product is a product of two limits.
Where's the h on the other one?
H on what other one?
Cosine x.
I broke it up. Yeah.
Well, now, wait. I think h is h times 1. I just broke up into fractions. That's a multiplication process. And if I plot a sine of x over here, just think of this. Would you guys agree? Because of my rather long geometric argument last time in class, would you guys not agree that this limit varies to 1? Oh shoot! As h does who cares what, the cosine of x just goes to cosine of x. Plus, well, as h does who cares what, I get the sine of x. Times. Oh no, you guys, this isn't going to work. If I plug 0 in for h, I get 1 minus 1 over 0, which is 0 over 0. So this is an indeterminate form. What do we do?
Are we going to massage it?
We're going to massage it. How do we massage it? Math D skills. How about math 8 skills? I said, how about math 8 skills?
Oh, yes.
Math 8.
Trig identity.
Try multiply by cosine
H plus 1.
I heard that. Cosine of h plus 1. Really slick. Because if you do this, what you get upstairs? You guys, please tell me if I'm skipping too much work. Be honest.
Yeah, how,
This.
maybe it's a silly question, but the sine of 0 over 0, how is that going to give you a 0 over 0 situation?
It does. That's why I spent 10 to 15 minutes last time in class. I used a really large
oh,
image
that's
for
right,
it
that's
to
right.
show you that really cool.
Got it.
I set myself up tonight.
Got it.
You guys help me with this. Is this cosine squared of h minus 1?
Yes.
Which is nothing more than,
Sine, sine squared of h.
yes, and I
Over-
think downstairs I get an h times cosine of h plus 1.
Yeah.
Oh shoot, I don't like what I'm writing. Just the cosine of x times 1, which is just cosine of x, plus the sine of x times something. But the something can be interpreted as a limit. As h approaches 0, can I just shave off one sine of h?
Wait, what did
Yes,
you
I'll
just
wait.
do? What did you just do?
In blue, Nabil, I just kind of combined these two factors upstairs. And think about it, watch.
Yeah, and then you got that, but then how'd you get to the next line?
He's just rewriting it.
From here to here?
He's gonna reduce it.
No.
Trig
and then
identity.
from
Here to here.
to there.
The cosine of x times 1 is the cosine of x.
Oh.
Sine
I
of
thought you
x
were
is
doing the
here.
limit part, and I was
Yeah,
like,
well, yeah, I'm not finished, I'm not
Oh,
finished.
okay.
But allow me, because check this out. If I shave off one factor sine of h, and shave off the factor of h, and then multiply by the limit of the other factor, which is negative sine of h, over cosine of h plus 1. Now when I evaluate this limit, when h goes to 0, what do I get?
1.
Oh, it's happening to say you care. You're right, you get 1, but when I plug 0 for h over here, what do I get? 0. Oh, come on, nobody jumped. What did I just show you? The derivative sine function is a cosine function. Is that smooth of a relationship? Now, in your past mathematical experience, you've had quite a number of intimate relationships between a sine function and cosine function. After all, your first Pythagorean identity said sine squared of x plus cosine squared of x equals 1. That is a huge intimate relationship between a sine and cosine function. You had your cofunction identities, the first of which said the cosine of pi halves minus x is sine of x. Another intimate relationship between a sine and cosine function. You are now raising your level of sophistication in mathematics to where we see another hugely sophisticated relationship between the sine and cosine function. Namely, cosine of x is really derivative sine of x. Humor me. What's the cosine of 0?
0.
1.
I'm getting confused.
It's 1.
Cosine of 0 is
1.
1. What the heck does that do with the sine function?
It means
Means
it's 0.
what? The cosine of 0 being equal to 1 means what?
Sine is 0.
We're up to what I've just done. The cosine of x, the cosine of 0 being equal to 1 means what? That the slope of the tangent line to the graph of y equals sine of x at x equals 0 is. That's a beautiful relationship. Look at what you just derived. Seriously, I'm serious. X-axis, y-axis. Here's the sine function. I think at x equals 0, the slope of the tangent line is a cosine of 0, which is 1. That is really cool stuff. There's only one problem. I made an assumption. I was assuming x is measured in radians. If x is measured in degrees, no way. I think the slope of the tangent line at x equals 0 is really nasty. It's only when you measure x in radians is the slope of the tangent line so beautiful at x equals 0.
So wouldn't the slope be 1 at every 2 pi interval as well?
Absolutely, because the sine function is periodic, you're going to duplicate that at every interval of 2 pi. As a matter of fact, if you look at this point, or this point, or this point, or this point, or this point, I think the slope of the tangent line, any of those given values of x, is going to be nothing more than the cosine at that value of x, because I just derived the fact that the cosine of x is derivative sine of x. There's a very beautiful relationship. Somebody rattle off the second Pythagorean identity, because we got a break coming up. What's the second Pythagorean identity? Tangent squared of x plus 1 equals secant squared of x. There's an intimate relationship between the tangent and secant functions. When we come up after the break, we're going to see that relationship is even stronger with the differential calculus. Another Pythagorean identity says that 1 plus cotangent squared of x equals cosecant squared of x. So again, after the break, we're going to see another hugely significant relationship, intimate relationship between the cotangent function and the because I don't want to. Because I think if I give you the derivative, which I will after the break, but I won't derive it out of thin air. If I did, it would take me another 15 minutes with a geometric argument. I'm going to say, slough off, you do it. But I promise you, next time you and I meet, I'll give you a much more sophisticated way of deriving the derivative of cosine of x. I'll still give it to you, but I'll have a better technique next time when I discuss a chain rule, whatever that is. Okay.
My original calculus professor, how was the chain rule?
What's that? Nabil?
Nothing.
Okay.
I was just saying that my original calculus teacher, when he was teaching us the chain rule, out of his desk, he pulled like these huge chains. He just started waving around. He was like, chain rule. It was really
I promise, I'm not going to scare you like that. I won't scare you like that. I won't do that. You guys, can we take our attendance?